Hi, and welcome to this presentation exploring confounding. So we're going to introduce the concept of confounding, explain what it is and what the criteria are. Then we're going to talk about how do we control for confounding. And because multivariable modeling is one of the most common methods to control for confounding, we will dig into that in a little bit more detail and conclude with a practical idea as a guide for identifying confounders. Okay, so a confounder is a variable that distorts the relationship between the factor of interest and an outcome. And what this means is that a confounder can only exist in the context of a study factor and an outcome. So to explain what I mean by that, imagine this. The question, is age a confounder, makes no sense unless we know the relationship in which age might be confounding. So for example, while age is age a confounder does not make sense, the question, is age a confounder of the relationship between neutering and mammary cancers, does. And so in order to answer that question, we have to see if age meets one of three criteria. The first is the variable is an independent risk factor for the outcome of interest. So in this case, the outcome is mammary cancers, and I think we can sort of safely assume that age is a risk factor for mammary cancer. The second question we need to answer is the variable, in this case age, unevenly distributed between the two groups? And so let's unpack what that means. What it's saying is, in practical terms, whilst you may believe that age could be a confounder because it's a risk factor, if age on average was the same in neutered and in tired dogs, then it couldn't be a confounder. So in other words, if they were balanced, so no difference between them, then in that particular set of data or that particular situation, age is not a confounder. Okay, we're going to come back to this because that balancing between the two groups is actually key to how a lot of methods for controlling for confounding work. And the final criteria that we have to ask ourselves is whether or not the variable is an intervening variable, because if it is an intervening variable, so in that case it lies on the same causal pathways relationship being explored, then it cannot be a confounder. So in this case, essentially what we're asking is, does the effect of neutering on mammary cancers run independent of the effect of age? And I think we can probably say it does. And that doesn't really necessarily help us understand what an intervening variable is. And I'd like to give you an example. And this comes sort of imagining a scenario in which we're interested in whether dietary fat increases the risk of heart disease. Okay, so we're looking at that, and then in that we might say, well, is blood cholesterol levels a confounder in that relationship? Okay, and so the first criteria would be, well, is it a risk factor? And I think we can pretty safely say, based on the literature, that it is in fact a risk factor. But this is where the sticking point comes in, and that is that the effect of dietary fat doesn't work independent of the blood cholesterol levels. Okay, so heart disease, so dietary fat increases blood cholesterol levels, which in turn increases cholesterol. Now, of course, there are other things, but if we were to measure both and try and put them in, we're essentially double dipping on the same process. So in this case, we would say that blood cholesterol levels cannot be a confounder of the relationship between dietary fat and heart disease. All right. So moving